Today I'm going to be talking about the relationship, the interactions between the Kirtland's warbler and the brown-headed warbler. Pictured here on the left side, I have a female brown-headed warbler. That's not what it is, a female brown-headed cowbird. And on the right side here, I have a male Kirtland's warbler. And so I'll go ahead and just start talking about what I'm going to be covering here today. So for full disclosure, I find cowbirds fascinating. And so I'm going to spend a lot of time talking about all about the cowbirds, all the fascinating things I know about them and have learned about them. So I'll be talking about the life history of both species, their remarkable adaptations, why I find them so cool and what makes them so special. From there, moving on into deforestation, forest fragmentation, which have made cowbirds a problem for a lot of species. Talking about how humans have tried to remedy that problem, especially with the Kirtland's warbler, to try to help that species. And finally ending on hopefully a positive, happy note to talk about success stories about the Kirtland's warbler. A little bit about me. So like Ethan mentioned, I'm usually an environmental educator. I'm in this weird transitory period where I'm the interim branch manager at Riverside Park, but usually you'll find me out in the parks with kids, leading summer camps and leading our NEEP trips with the surrounding schools. The reason I'm giving this presentation today is because I was a student researcher at UW-Madison. I got to be part of a team of researchers that got to spend the summer in Adams County, Wisconsin. I got to study the brown-headed cowbird. I got to track them and follow them around, observe them for a whole summer. Meanwhile, my team was working with the Kirtland's warbler. So I got to see tons of the Kirtland's warbler, but I didn't get to work as closely with that species, which is why today I'm going to be really focusing on the brown-headed cowbird. So let's jump in. So the brown-headed cowbird, for those of you who may not know, it's mainly found in grasslands and open pastures. They really like the forest edges. You won't find them as commonly inside of forests, especially really dense, big forests, though you may still see them parasitizing some nests in those areas. But mainly you're gonna find them in those really big open areas. In the winter, you'll see that they roost amongst other blackbirds. Those roosts can get as big as 100,000 birds, 100,000 individuals, which is incredible. Cowbirds feed on seeds, grains, and insects, which brings us into why it's called a cowbird. So they used to be found following cattle, herds of buffalo that were grazing. And so as the cattle, the buffalo were grazing and moving around in the grasses, they would disturb all the insects that were living in the grasses. And so the cowbirds could easily just come in and swoop in and get their feed. They could eat those insects. So because they were following the cows around, they called them the cowbirds. And so the more interesting part of the cowbirds, what they're most infamous for, are being obligate brood parasites. So they are out here not knowing how to build their own nests, so they rely on laying their eggs in the nests of other species. And so that's where the obligate comes in. They absolutely need to rely on this reproductive method in order to pass on their genetic material. They are incapable. They do not build their own nests. They could not rear their own young. And so they rely on other species to do that for them. This is a pretty rare quality. Less than 1% of all bird species rely on this reproductive strategy. And so here I have listed a few of them. And these species or groups of birds occur across the world on different continents. So the one that we have here in North America is the brown-headed cowbird. In Europe, they have the cuckoos. In Africa, the honeyguides. And in South America, they just have this one duck, the black-headed duck, that is an obligate brood parasite. Now we see that other species will do intraspecific brood parasitism. So that means that within one species, they may lay their eggs in the nests of other individuals. And that's much more common. This method of being an obligate brood parasite is much less common. And so some ways that they've been able to accomplish this, so some adaptations that they have, we can see in this picture here, what we call egg mimicry. So this nest here, I'm not sure what the species is, the host species, but what we see is that an old world cuckoo laid an egg. So this bigger egg on the upper right-hand side is the egg of the cuckoo. It looks pretty similar to the other eggs that are in this nest. It's a little bit bigger, maybe a little bit greener or darker shade, but it looks pretty darn similar. Cowbirds do not rely on this because cowbirds do not specialize on parasitizing just one species like the cuckoos usually do. And so down here we see that I believe it's an eastern phoebe nest down here in the bottom left corner. And the cowbird is that bigger speckled egg, doesn't look anything like the phoebe eggs. And so they don't rely on egg mimicry. They have other adaptations that help them. One of them, and this is also an adaptation of the old world cuckoos, is that their eggs will have harder shells. So the cuckoos, when they drop their egg into the nest, with that harder shell, it might damage or crack some of the other eggs in there without harming the parasite eggs themselves. So that's an adaptation there. And especially, this last one is especially true of the brown-headed cowbird, that they have shorter incubation periods. And so what we'll see, like in this phoebe nest, is that this cowbird is going to develop quicker. It's going to hatch first. And so it's already going to be a few steps ahead of those phoebe eggs. And what ends up happening there is that the host bird mom is going to give a lot of its energy to this bigger cowbird that hatched first. It's going to see it as the stronger bird, as the one that's most developed, the most likely to make it out of the nest and be successful. And so it might start to neglect its own eggs, unfortunately, to the point where sometimes their own hatchlings starve because they spend so much energy, so much time feeding that bigger cowbird that was born first. And now the question of why. Why would birds do this? What is the advantage? Granted, right, like that sounds like a sweet life, not having to take care of your own young, depending on someone else to do it for you. And so that's one of the advantages. They don't have to spend that energy on rearing their own young. They don't have to spend that energy feeding them and teaching them all the things they need to know before they become fledglings. And they also get to save the energy of not having to defend a nest, right? Instead, all their energy is going to go into breeding and into laying the eggs. So in a season, a brown-headed cowbird can lay between 30 to 40 eggs, which is so remarkable because most birds aren't going to be able to do that. Most species won't do that. They may be able to successfully have 2 clutches of eggs, but even then, they may get into the double digits in terms of the success of their fledglings. They're not going to get even close to the 30 to 40 eggs that the brown-headed cowbird will put in a season.
We have our first couple questions, if you're interested in taking them.
For sure.
The first question is, where do they winter?
So that's a great question. I wish I had included a range map in here. Maybe I can just pull one up really quick.
Or we could use the community and put the people watching to Google searches and see where their range is.
I think I might be able to pull one up here really quick.
I can give a lecture eventually on how to use eBird to look at all the range maps of all the species. It's pretty helpful. So, there you go. All right.
Yep. So their non-breeding is down here in the blue. Their breeding is up here in the orange, and year-round they're here in the purple. So mostly in Wisconsin, they're here during the breeding season, and they're overwintering further south, as far south as Mexico, but even just in the southern United States, we'll find them.
Wonderful, thank you.
Mm-hmm.
The second question is, do they typically just put one egg into the into the nest that they're parasitizing?
Yep, so it's usually just the one egg.
Okay, great.
Any other questions before I keep going here?
Nope, that's so far what we have. Thank you.
Mm-hmm, for sure. Okay, and now one of my favorite terms ever. I learned this one in my ornithology class in college, the evolutionary arms race. So that's what ends up happening between the cowbirds and the species that they parasitize. And so what we saw happen, and not in person, we didn't see it, but what has happened is a coevolution between the species that were parasitized by the brown-headed cowbird and the brown-headed cowbird. And this means that the cowbird didn't just win. It doesn't just get to put its eggs into other nests and say that they have a successful next line, next generation. Instead, what's happened is that those species got to co-evolve along with the cowbird, and they have different adaptations to try to combat the parasitism. For example, gray catbirds can count their eggs. They know how to count. And so if a gray catbird decided to leave its nest for a few minutes, it could count and say, I have 4 eggs in this nest. If a cowbird comes while that catbird is gone and lays another egg, when the catbird comes back, it'll know there is 1 more egg in here than before I left. And so it has a few options there. It can continue to raise that clutch of eggs. It could abandon the nest. It could rebuild a nest. But that's a huge deal, right? That was a huge adaptation for the catbirds, that they were able to identify that there's an extra egg in there and could act accordingly, right? But from there, the cowbirds also figured out that they were being less successful, and of course, consciously they didn't figure this out, but they acquired the adaptations to be able to combat that, and started to I'll show you in the next slide some videos, started to expel or reject or take out one of the eggs of the original brood. And so the cowbird figured out, well, the catbird knows that if there's a 5th egg in there, it's not going to accept it. It's not going to raise my young. And so if I kick out one of the original eggs, the catbird may not know that one of its eggs has been replaced by my egg. Now, the yellow warbler is able to identify a foreign egg, so it can differentiate, right? When we saw that speckled egg earlier, the yellow warbler would have been able to tell, that's not my egg. I'm not going to raise that. And so what they do instead, they'll rebuild their nest over the previous clutch, because that's preferable to them over having to raise a cowbird hatchling and potentially having that hatchling outcompete its own young. And this one's interesting to me, the American robin. So this hasn't happened across the entire American robin population, but some populations of American robins can identify the cowbird egg and can reject it and kick it out of its nest. And what happens there, the reason that isn't always preferable is because sometimes they'll damage their own eggs in the process. But those are some of the adaptations that other species have acquired to combat the parasitism from the brown-headed cowbirds. Now here I have a couple of videos. Ethan, can you let me know if it's sharing to the next open tab?
Yep.
Okay, perfect. I'm gonna keep the sound off here, but what we have happening is a female brown-headed cowbird comes into a northern cardinal's nest. There are 2 eggs there to begin with. I'm going to speed forward because this video is only 2 minutes and 30 seconds, so it doesn't take very long for this process to happen. But at about 50 seconds, we see that the cowbird laid an egg. And then we get to see what it does from there. So there it is, ejecting one of the cardinal eggs, and it doesn't stop there. It goes on to start pecking the other cardinal egg that was left. So even if the cardinal egg was successful, the one that was left, even if it could figure out how to compete against the cowbird hatchling, well, now it won't even get that chance because the cowbird is messing with both of the original cardinal eggs. I'll stop sharing there. And move on to another video here. This one is super silly to me. As you can tell by the title, it's a chickadee that's feeding a cowbird fledgling. So the chickadee, even though it's feeding a bird that's twice its size, it doesn't even realize it's not its own young, right? So, so those adaptations that I identified earlier are actually super significant because some species can't even tell once the fledgling is bigger than itself that it is not its own young.
That might lead well into one of the questions. The question of what keeps the baby cowbird from being imprinted by, say, the adult warbler instead of the cowbird? So how does the cowbird learn that's a cowbird?
I think I might get into that in the next slide. So perfect. Yes. Let's see if that's true. Yes, the cowbird identity crisis. That's a great question because, yeah, most birds are going to imprint on the first moving creature that they see. Now that happens to different extents, right? For some, it's right like a human, right? It'll imprint on a person. For most birds, it's not that extreme, but you would think they would imprint on the first bird that they see, the first mama bird that they have, right? So why didn't that cowbird start acting like a chickadee? Why didn't that cowbird hatchling or the one in the egg start acting like a cardinal? And so there was this cool study done by Mark Haber at Hunter College. And what they found is that cowbirds use what they call a vocal password. And so when a hatchling is really young, just a few days old, as soon as they hear a cowbird chatter, they're able to identify, oh, those are my people, not necessarily people, right? But that's my population, that's my species. And they're still looking into what it is in the brain that's signaling that allows them to immediately recognize that as their species. But it indicates that it's an innate adaptation that they have that allows them not to necessarily associate the host parents of the nest as their own species. So there's something funky happening in the brain that is triggered just by the sound of the cowbird chatter, which is really interesting. Okay, before I move into the Kirtland's warbler, are there any other questions about cowbirds? I'm happy to take even more at the end, but I figured this is a good chance to stop.
There was one more question. Do baby birds learn behavior from the host or the real parent? You might have alluded to that just now, but.
Wait, repeat the question, sorry.
Do baby birds learn behavior from the host or the real parent?
I'm not positive what the answer to that question is. Because cowbirds overall have their behaviors, right? I'm imagining they don't learn anything that they don't have to learn, if that makes sense. They're not taking in any behaviors from the host parent that wouldn't be what's the word? Advantageous to them. That's a guess, but I'm not positive.
That's how I understand it too, Lucero.
Okay, cool. Thanks, Tim. Cool. So moving into the Kirtland's warbler. I did my best to include as many pictures of this species because I think they're super cute, right? They're not, there's other warblers that look more more unique, but I think the Kirtland is a pretty cute one. They winter in the Bahamas. For the most part, they nest in a small pocket, a forest in Michigan. But now they've also been found in Wisconsin and Canada, which is very exciting. They are habitat specialists, and I included a picture of a nest here, the Kirtland's warbler with its nest, so you could get a little visual of how it is they build their nest, because it's pretty different from other species. They build them in the ground and in little cups underneath jack pine branches. And so this is where the specialist part comes in. For the most part, they will only breed under jack pine trees. And they need stands of jack pines that are at least 80 acres, but they much prefer for that to be much bigger. Over 400 acres is what they prefer. And the reason that they choose the jack pine is because jack pines have low hanging branches. And so those low hanging branches allow for their nests to be hidden. Right underneath them, they're able to use the litter from the jack pines and other jack pines and the shrubs that are around to create the nest. But it's those low hanging branches that they're really going to rely on to help them hide their young. What's also special about them is that the jack pines have to be pretty young, so under 15 years old. And once the jack pine reaches 16 feet in height, they will no longer use those jack pines to breed under or to build their nests under. And so what we see happening is that these jack pines are small. They're all about the same size, and it's very sunny in those areas because those jack pines are so short. Once those jack pines get tall enough, the lower branches of the jack pines aren't getting enough sunlight, and so they'll start shedding those lower branches. And that's why once they reach a certain age, they no longer can use those jack pines. Yeah, I'll move into the next slide here. And something else to note that we've mentioned before is that it is a federally endangered species. And what makes them extra special is that, or what has limited their habitat, is that these jack pines rely on wildfire to regenerate. And they need to grow in sandy soils because they need the water to be able to drain in that soil so that their nest can stay dry. So that's a pretty specific place that it's pretty specific requirements that they need to be able to nest. And so what we've seen happening because of fire suppression is that we just don't have enough of those young jack pine stands anymore. So before European colonization, half of the continental US burned every 1 to 12 years. And so comparing that to how many wildfires we have now, right, we definitely aren't getting that amount, nowhere near close. And jack pines need that fire. They need high temperatures in order for their cones to open to be able to disperse their seeds. And so these fires are what allowed for these young jack pines to continue growing, for there to be, for that habitat to be replaced over and over for the Kirtland's warbler. And so we're not seeing that happening anymore. In addition to that, we have forest fragmentation. And so that already limited the habitat, right, that the Kirtland's warbler would have had, but then it also allowed the cowbirds to expand their range eastward. And so, you know, earlier I was talking about the coevolution between cowbirds and other species that they parasitized, but what we've had happen is that now species that didn't used to interact with the cowbirds suddenly have to figure out how to combat the parasitism of the cowbirds. And so the Kirtland's warbler does not have those adaptations to combat it. In addition, cowbirds love that open, right? The open grasslands, the open areas. So there's even more edge effects happening because of forest fragmentation, which means that we get even more parasitism from the cowbirds affecting other species that they didn't used to parasitize. Let's see, is there anything I didn't cover here. No, so cowbirds, bad for the Kirtland's warbler. Overall, I love cowbirds. I think they're super cool, but this is where the problem comes in, right? This is where they become problematic. This is why they have that infamy now, and why they've become so problematic to so many species. So here are some stats. So in 1957, that was probably the first time that they were really taking a look at the Kirtland's warbler nests and tracking parasitism. And they found that 55% of nests were parasitized. And so someone asked the question of how many eggs will they lay in a host's nest? Just one is enough for the rest of the nest to not make it. And so looking at that number, over 50% of nests were being parasitized. That could have been up to 50% of nests that were not successful of the Kirtland's warblers. Then from 1957 to 71, they saw that 75% of nests were parasitized. So things were becoming dire for the Kirtland's warbler. Over 10 years, between 1961 and 71, they were tracking the population in Michigan of Kirtland's warblers males, and they found that the population had gone from 500 to just over 200. And so now we'll get into the work that I was a part of, because it was happening here in Wisconsin, in Adams County. And the Kirtland's warbler was first found there in 2007. And I can only imagine what it must have been to be that person that heard the Kirtland's warbler and was like, what? Like, there's another population, there's another individual somewhere else besides Michigan. And what's really interesting about Adams County is that it's not a jack pine stand, it's a red pine stand. It's a commercial red pine stand where jack pines used to grow. And so what they had happen there is that between these stands of red pines, they had random jack pines starting to grow. And they were densely planted, the red pines were, because it was for commercial purposes. And they saw that the density was really similar to jack pine forests. And so like I mentioned, those jack pines are going to lose their lower branches. They're going to grow on sandy soils. That's the case in Adams County. It's super sandy there. The red pines grow really well there. And so what they're finding is that it's suitable habitat for the Kirtland's warbler, and they have similar success nesting in those red pine stands as they would in a jack pine forest. And so here's a map of the three places, the three counties that the Kirtland's warbler has been found in Wisconsin. So Adams County is here in, it's the blue spot in the middle. So that's where I was based, in central Wisconsin. They're also found in green over here, that's Marinette County, and Bayfield up here in red. I believe in Bayfield, they only get a breeding pair per year. In Marinette, it's less than 5 breeding pairs. It's really in Adams County where most of them are. And even then, the population is not big at all. I think the summer that I spent there were maybe 16 breeding pairs. And in 2018, they found 22 breeding pairs. So the populations aren't big, but it's still pretty darn cool that they're found in other places. And just to get an image of what it looked like there, what their habitat is like, this is a picture of the site, one of the breeding sites in Adams County. So you can see it's super sunny. These pines are pretty short. And yeah, you can see why a cowbird would parasitize nests that are found in these areas, right? It's open enough. It doesn't feel so much like a full-grown forest, right? So it's perfect for both the Kirtlands and the cowbirds. And so moving into my project, and actually before I even say that, I'll go back and say that these red pines retain their lower branches lower than jack pines will. And so it's really exciting that they're finding them breeding underneath and using red pines because they're able to retain those lower branches. So maybe they'll be able to use these nesting sites for longer than they would if they were just jack pines. All right. so my field work, I it was not glamorous work. I was tracking cowbirds, and so what that meant, there were already these traps that looked really similar to the one pictured here that were for cowbirds. And the way these traps work, there's an opening at the top of the trap, and there's food there. And so it's attracting the cowbirds. Sometimes we would get other species in there, but for the most part, it was blackbirds that were being caught in there. And it was almost like a funnel kind of trap where once the cowbirds made their way in, they couldn't figure out how to get back out. And so these traps were just around the breeding sites of the Kirtland's warbler. And once these cowbirds were caught, they were euthanized. That's the management that's happening in order to help the Kirtland's warbler. It's just lowering the population of the cowbirds where the Kirtland's warbler exists. And so I would go inside those cowbird traps. I would get a net and trap a cowbird. I would catch one in there. And from there, I was catching the female cowbirds. I would tag them, and I would place a radio transmitter on their back. So we had a really small team. We worked really closely together, that research team, at the start of the summer, but as time went on, we spent much more time working individually. So I don't have a lot of personal pictures, unfortunately, and I had to pull these other ones up. So I included this picture of a little baby cowbird down on the right-hand corner. And you can see that little antenna poking out of its back. So that's what I would put on my cowbirds to be able to track them. And there were quite a few things that went into that. Like, I think it had to be like less than 3% of their total body weight, so that I wouldn't disturb them. They would still be able to live their lives regularly. And we would let those cowbirds go, and then my job was to find them again. And so 3 times a day, Monday to Friday, I would go out in a car with an antenna on top of my car, a receiver inside the car. So I was constantly hearing static until I drove close enough to one of my cowbirds that the radio transmitter, we were able to pick up the signal. And so I'm hearing static until suddenly I hear beep. About every 3 to 5 seconds, I would hear it if I was close enough. So I'd get super excited once I found my bird. I'd get out of the car, like this person pictured here. I'd come out with my antenna, with a handheld antenna, and try to track my cowbirds. Sometimes I would go out and just try to get as close as possible and actually get a visual of my cowbird. Other times it would be on private property, or I just didn't have the time to track all 10 of my cowbirds with a specific location. So instead, what I would do is use radio telemetry. And so the way that works, I would pick a spot where I could pick up the signal from the radio transmitter on my antenna. I would take a GPS coordinate of that location and then use a compass to get a bearing of the direction that the cowbird was from me. I'd choose a second point and do that again. And we would use triangulation to figure out where those points crossed. And presumably that would be the location of my cowbird. And the reason I was going out 3 times a day was to figure out where they were roosting, where they were feeding, and where they were mating, because presumably they do those things in 3 different locations, in three different sites, but they'll congregate with other cowbirds while they're doing that. And so that information would then be used to figure out where the cowbirds that were near the breeding sites of the Kirtland's warbler were, so that we could more accurately and just get a better sense of where we should be putting our traps, those big traps that I had pictured in the beginning. So that, because that was the management, right? We would put those traps in the right location and be able to euthanize the cowbirds that were near the Kirtland's warbler breeding site. I'll stop there for a second and see if there are questions.
There aren't any other questions at this time, but
Okay.
we'll have more.
Cool. So I'll move into So the positive end of this story. So the Kirtland's warbler nearly went extinct in the early 1970s, right? Their populations had gotten down, or their population had gotten down to the hundreds, which is incredibly low. And the US Fish and Wildlife Service set a recovery goal so that by the early 2000s, the population would reach a certain size. And since then, that population goal has been exceeded a few times, and the population is much higher than the goal they had set for themselves. Right now, there are over 2,300 breeding pairs, which is fantastic. And so the next point here is that they've been able to colonize new areas, and I have that in quotations because I don't like that language very much, but that's just how we talk about it in terms of animals, that they have been able to find new areas to thrive in and successfully live in. And the reason that's really great is because if something were to happen to just one of these populations, at least we would know that other populations exist, right? So if there's huge population that occurs in Michigan, in northern Michigan, if something were to happen there, then at the very least we would know that these populations are occurring in other places, because the Kirtland's warbler will continue to go to the same breeding sites year after year. So even though their population is super small in Wisconsin, at least there are other populations outside of Michigan. And I tried to do research on this, and I'm still not positive. I think it has been removed from the federal endangered species list, or is in the process of being removed. But in Wisconsin, it will remain on our state endangered species list, which means that they will still get funding. There will still be resources and just plans to protect this species, because the population is so small here, and it would be really great to have another established larger population outside of Michigan. So that's what I have for you all today. And I wanted to leave the rest of the time for questions that you may have.